Hello, this is Gabriella, and this is my Fluids project. So I began by dragging Fluent onto this project schematic, and then I'm going to right-click Geometry and open up the Design Modeler. Awesome. Okay, so I want to do everything normal to the XY plane. So I'm going to click on this Z. I'm going to click on this plane, and I'm going to make a new sketch. Click over here on sketching. Let's make sure that my units are in millimeters. Let's get a little bit closer because they're a little far out. All right, so the dimensions that I chose to go with were 4 millimeters and 200 millimeters. I'm going to click on this rectangle. I'm going to try and hit that origin. And too many things on my desk. All right, I'm going to click dimensions and click on these edges. So this is going to be 4 for me. Oops, 4. And this top one is going to be 50 times that. So 200 if my math is correct, which I hope so. All right. I'm going to go over here to concepts, surfaces from sketches. I'm going to box select this whole thing. So let me zoom out so I can grab it all. And I'm going to generate. And now I have a surface. So now I'm going to switch over back to Workbench. I'm going to double click on Mesh, and that should open up my new window. Sorry for the sniffles. Okay. All right. Okay. Let's explode this view. Awesome. So we're going to look at it via this way. And I'm going to do the same meshes that Dr. Osbe did. So insert, method, and I'm going to select this geometry, apply, and generate. And it should look something like this. Now I'm going to insert some sizing. I'm going to make sure that I'm selecting the edges. Apply. I'm going to do number of divisions. And what did I do with my thingy? I think I did 80. So I'm going to go with 80 again, just to keep things consistent. And generate. That warning message, I looked it up on YouTube, and apparently it doesn't mean anything for my purposes at the moment. I'm gonna go ahead and insert sizing again, this time for that top surface and that bottom surface. Apply. Make sure I'm doing number of divisions, and I'm gonna go with 400 and generate. Okay. And then finally, I'm going to add a face meshing to the entirety of the surface and generate. Alrighty, and it looks all black, but once I zoom in, we can see there's a bunch of little grids, and that's exactly what we were hoping to get. And so now the last thing I'm going to do in this window is I'm going to name every single edge. So this one for me is going to be my inlet. And this one out here, my outlet. This will be my top wall. And this one will be my bottom wall. Okay, all good. So I'm going to go back to my workbench. I'm going to update my mesh. And I'm going to continue to set up. I'm going to make sure that I'm clicking double precision, and this is all set, and start. I'm going to. So I'm going to drag this over once it finishes loading up. Okay. Oops. Not what I wanted to do. Okay, there you go. All right, so from here, we're going to make sure that we are working in laminar. Oops. Okay, laminar, which means that my Reynolds number has to be below 2300 or 2100. I chose a Reynolds number of 2000, and that's what my viscosity and my velocity were based off of. So I'm going to go ahead and I'm going to go to materials, fluids, and I'm going to click air. I'm going to change my density to 1 because I chose it to be, and my viscosity is going to be 1 to the negative 5, if my handy calculations are correct. Alrighty, and I'm going to close that out. I'm going to make sure that this is also air, which it is, so that's great. I'm going to go over to my reference values. Oops, my boundary conditions, my bad. We're going to go to inlet, make sure this is velocity inlet, which it is. I'm going to edit so that this is 5 meters per second, the velocity that I selected. Close this out. I'm going to make sure that all the walls are stationary with a no slip condition. Awesome. Let's check out this bottom wall as well. Cool. And let's make sure that this pressure gradient is 0, so that there's no pressure change. Awesome. So I'm going to go to reference values and I'm going to compute from my inlet. And I'm going to make sure that I initialize. And now let's run that calculation. I'm going to do 200 iterations. Awesome. So let's go over and make those vectors so we can kind of see what that looks like. Save display. And I can't see because my laptop's in front of the way. So close this out. Let's give this a nice zoom. And yeah, that looks pretty good. That's what we wanted to look like. So now what I'm going to do is I'm going to go back to my workbench. I'm going to double click on my results. Now, back just a second. I'm going to drag that over. All right. So first things first, I'm going to make a contour. Let's call contour 1. My location should be the entirety of the symmetry. And my variable is the velocity u. I'm going to make this around 100 so that it looks nice and smooth. Awesome. And as you can see, there's that formation of that boundary layer as we get further into the geometry. Let me change how that looks. That's not so much in the way. Horizontal. Let's do fixed and let's do 2 decimal. Okay, looks good. So I'm going to shut this off for just a second so that I can get my midpoint and my endpoint in place. And so my entirety of my length is 200, so my midpoint should be 100. But this is in meters, so 0.1. My height, 0.004. Let's do 100 samples. Okay. And one more for the endpoint, but for this one, I'm not going to go all the way to the end. I'm going to approach that end so that I can see the velocity as it approaches the end. So let's do 199. And do that. 4. And let's see if those samples 100. And do I like that? I think I could get. Okay, so now I'm going to go ahead and add a chart, and we'll call it velocity profiles. Let's go data series. We'll call this one midpoint. Location, midpoint. For the x-axis, this should be velocity u, and the y should be just y. And apply. Looks good. We're going to go ahead and make another one for the endpoint. Repeating that same process, double check that that's okay, and apply. Alrighty, looks good. So now we're going to switch on over back to Workbench, and we're going to go ahead and try and make those changes for the coed flow. So actually, let's go back to setup. I'm going to exit out these velocity vectors. I'm going to change the viscosity of my air to so 4. Close. We're going to go to our boundary conditions because now our inlet becomes a pressure inlet. Okay. 0, 0, looks good. Apply. Close. And our top wall now moves. So let's change that to moving. And I chose a speed of 0.5. All right, let's make sure that those reference values are still from the inlet. Let's initialize. It's good. And let's run that calculation. Okay, cool. Let's go ahead and make those vectors. Let's have them displayed. Nice closer look. Looks good to me. Alrighty. Now let's go switch over to those results, and it should automatically update. Yes. As you can see, it reaches that linear because we don't want it going back. Let's go ahead and click 3D viewer so we know what it looks like. Let's turn that contour back on. It looks good. Alrighty. So for that mixed flow, I'm going to go back to my setup. I'm going to change my viscosity back to its original viscosity to make sure that that's correct. Checking my sample calculations. All right, yeah. We're changing the viscosity back to 1. Looks good. Okay. We are going to change our inlet velocity. Let's go back to the boundary conditions. This becomes velocity inlet once again. And we're changing that. Should be 5. Shouldn't have changed. 5. Close. And now this top wall velocity will also be 5. Apply and close. Let's make sure those reference values are from the inlet. Let's initialize. And let's run that calculation. Mm, okay. Let's have a look at those. It's me. All right, let's go over to our results. Yes. Looks good. And as you can see, sort of towards that end, like not exactly where we are, but you kind of see that formation as well. It starts to get that color lightens to kind of represent that boundary layer. See if we can get that chart viewer updated as well. There you go. Alrighty. Looks good. That is the entirety of my first Fluent project. Thank you.